Question of the Week from the Naked Scientists.
Hello and welcome to Question of the Week. I'm Otis Kingsman, and in today's episode, we'll be tackling this battery baffler from listener Tibble.
Does potential energy have any mass? If I were to charge a phone battery, would it become heavier?
From phones to TV remotes, it's commonplace to describe batteries as full or empty depending on their charge. So surely it would make sense for them to get heavier, right? Dr. Israel Temprano from the University of Cambridge has a few things to say that will change our understanding of how it works.
So potential energy is a term in physics related to the distance that a certain mass has in any potential well. So this relates to how high an object is. So if you have an object that is standing very, very high and you let it go, it will start moving, and then it will trade its potential energy to kinetic energy. That's not how we store energy in batteries.
It turns out these are two very different questions, Tibble. As you drop an object from a height, potential energy is transferred into actual energy through heat and movement by falling down. Therefore, the potential energy of objects held up doesn't give it any extra mass. But then, what happens when we charge a phone battery?
So the common batteries that we use in our everyday electronic devices in electric vehicles and such is what we call a lithium-ion battery. Lithium-ion batteries work by just moving lithium ions, which is positively charged lithium atoms, from one side of the battery to the other. AA and AAA batteries, they have a different architecture inside, but again, all you're doing is moving components from one side of the battery to the other.
As the ions move to the other side of the battery, electrons move out of the battery and into the phone, where it generates electricity, before going back into the battery, but on the opposite side.
In order to balance the charge, electrons have to follow these ions. And what we do is force these electrons to go outside of the battery. And this is why we call this type of battery a rocking chair, because we're just moving things from one side to the other. And it's this movement of electrons that we use to power our portable devices.
When we charge a battery, we are moving the electrons out of the device and into a wire, before new electrons go back in on the original side of the battery that it started on. This resets the battery, and the process can start all over again. Overall, there will always be the same amount of electrons and ions within the battery.
So, no, when you charge one of these batteries, all you're doing is moving components from one part of the battery to a different part of the battery without adding anything to it.
However, while current batteries don't change weight when charged, there may be some in the future that do.
For example, one of the most interesting is our lithium air batteries, which we investigate in our lab. Now, these batteries move, again, lithium ions from one side to the other of the battery. But at the other side of the battery, what they do is they recombine with oxygen from the air, and they form some crystals. And these crystals grow in the cathode, in one side of the battery. So when you're discharging the battery, you're growing these crystals, partly from what's inside of the battery and partly from air. So the battery is gaining weight. And then when you charge it, what you do is you decompose these crystals, you move the lithiums back to where it were at the beginning, and the oxygen returns to air. So the battery is losing weight as you charge it.
Thank you to Dr. Israel Temprano for helping us find the answer. Next week, we'll be finding the answer to this head spinner from listener Linda.
Can the spinning of the Earth be used as a source of electricity similar to the spinning of wind turbines?
If you at home have a question, submit it to our website, nakedscientists.com, put it on our forum, nakedscientists.com/forum, or email us at chris@nakedscientists.com. I'm Otis Kingsman. Thank you for listening, and I'll see you next time.
Question of the Week is part of the Naked Scientists podcast and supported by the Wellcome Trust and UK Fast. Look us up online at nakedscientists.com.